when I am riding a two-wheeler vehicle, just by changing few forces, if I put some forces to one side or to another side, I can handle the vehicle, which we cannot do in a four-wheeler vehicle. So suppose this is your tire. If it is inclining in one direction, so the angle it is making between the vertical axis to the inclined axis, so that is the camber angle. Whenever your vehicle is going to incline in one direction, so that is going to maneuver your vehicle in one direction. So higher thrust, that means it will give you a positive force, so that it will come back to its original position more easily. We will not be able to come back to the original position if the camber thrust is not proper for a tire. After that particular angle, it may skid, it may fall down, so the possibility of returning back more easily will reduce. In a physical test, I never can see that, like how much stress is being generated inside the tire. So that only we can see through simulation. Before manufacturing a tire itself, we can model the tire, we can check the design, and we can get an idea like how much force and movement it is going to generate when it will be manufactured. SIMULIA Abaqus has some capabilities which helps us to perform tire simulation very easily. I can model the reinforcement layers or the rubber coated fabrics very easily using the river layer, and Abaqus is also very much accurate to predict that particular result. A tire manufacturing is a tedious process. Suppose if I want to manufacture 4 iterations, so that will take me at least like 2 weeks each, so that is going to take me 1.5 months. So which can be done starting from like scratch meshing and all, so it is going to take me hardly 1 week. Using SIMULIA gives us a confidence because it also like introduced my many new material models which can be more accurate as what we were using previously. SIMULIA is the best suitable tool to perform the final element analysis of a tire. SIMULIA is going to help us to validate our designs, whatever we will make.